Welcome to your personalized deep dive. We're taking a look at the Headfirst Object-Oriented Analysis and Design book today.
Oh yeah, this one's
It's known for its visual and engaging style, so it's perfect for learners like you who want to actually apply this knowledge, not just memorize it.
it's definitely a good one for that for
Yeah.
sure. Uh,
Now, it does assume that you already know some Java,
yeah,
so we won't really be covering like the basics of the language here.
right. It's really more about taking what you already know with Java and then leveling up to actually designing whole software systems.
Oh, that's cool.
Yeah, the kind that won't give you a headache later on when you need to, make changes.
I like the sound of that.
Yeah.
So the book starts off with a case study about this place called Rick's Guitar Shop.
Yeah, Rick's Guitar Shop.
Can you tell me a little more about that?
Well, Rick owns this guitar shop, and he wants an application that's going to help his customers search for specific guitars,
Okay.
based on all those details that guitarists love, like the brand model wood type, the whole shebang.
Yeah.
But the application he has currently just isn't flexible enough.
So what's wrong with his current setup?
Well, initially, his application is built on just like simple guitar and inventory classes.
Okay.
So if you think about it, the guitar class is like a tag that holds all the guitar's properties, like serial number, price, who built it,
Yeah.
model, types of wood, all that stuff.
Okay, so it's just like one.
Yeah. And then the inventory class is kind of like the big box that holds all those guitar tags.
I can picture that.
Yeah.
So where does it start to fall apart?
Well, the problem is that the search logic is built directly into that inventory class.
Okay.
So every time Rick wants to like add a new search filter, it's like he has to rebuild that whole box. Yeah, it creates a ton of duplicate code. It's hard to maintain, and it's really not efficient.
It's like building a house of cards.
Yeah, exactly. One wrong move, and the whole thing collapses.
That doesn't sound very good.
No, not at all.
How do we fix that?
Well, this is where the idea of what's called encapsulation comes in.
Yeah.
And the book uses Rick's Guitar Shop to illustrate how this works.
Okay.
So they introduced this new object called guitar spec.
Guitar spec.
You can think of it like a separate detailed spec sheet that goes with each guitar tag in the inventory box.
Oh, okay. So instead of having all those details scattered around, you're creating like a dedicated space for them.
Exactly. Guitar spec neatly packages all those key properties, and by moving the search logic to the guitar spec class, the code becomes much easier to manage and change.
Okay.
So if Rick wants to add a new search filter, you only need to update guitar spec.
Oh, so you're not rebuilding the whole inventory box every time?
No more rebuilding the whole box, thank goodness, right?
So encapsulation is kind of like creating this like black box for your code.
Yeah.
It's like hiding the messy details inside.
Right,
And then just providing this clean, simple interface to the outside world.
exactly.
It's easier to understand, it's easier to maintain, and it's easier to reuse.
For sure.
That's really helpful.
And it applies beyond software too.
Oh, really?
Think about organizing your workspace, or even your thoughts.
Okay.
Encapsulation can help you manage complexity and create these modular systems in any field.
That makes a lot of sense.
Yeah.
But before we get too excited about encapsulation, the book makes a really big point of, understanding your customer needs.
Right.
Like it's about building what the customer actually wants, not just what we think they want.
Oh, absolutely. And that's where use cases come in.
Okay.
A use case basically helps you define what a system should do, like a step-by-step guide.
Okay. Can you give me an example? Because I need one.
Sure. The book uses this example of Todd and Gina, who want to build a dog door for their furry friend Fido.
All right. I'm intrigued. Tell me more about this dog door.
So the goal is to create a door that lets Fido outside and back in, without any accidents.
Yeah. Keep the squirrels out. Keep Fido from getting into trouble.
Exactly.
Makes sense.
So the basic flow is pretty straightforward.
Right.
Fido barks, the door opens, he goes out, does his business, barks again,
Hmm.
the door opens, he comes back inside.
Simple enough, but what about like edge cases?
That's a great question. Real life is rarely that straightforward.
Yeah.
The book points out that you need to think about all sorts of possibilities, like what happens if Fido gets distracted outside and doesn't come back in right away?
Yeah.
Or what if the door doesn't close properly?
Oh, then you've got a yard full of unwanted visitors.
Exactly. That's why analyzing these use cases is crucial. It helps you anticipate potential problems and design solutions before you even write any code.
Yeah, you could add a timer to the door.
Right.
That automatically closes after a certain amount of time.
Exactly.
So you prevent any escapes or unwanted intrusions?
That's a clever solution.
Yeah.
So it's not just about listing the steps, you know.
Yeah.
It's about thinking through all the what-ifs and potential problems that might arise.
So how do we go from these use cases to actually designing the software?
Well, we need to analyze the use cases to identify the potential objects and how they're going to interact.
Yeah.
And the book actually highlights this simple but effective technique. Just focus on the nouns.
Oh, okay. What's so important about the nouns?
Well, nouns in a use case often point to the objects or classes that you're going to need in your software design.
Okay.
For example, in that dog door scenario, we see nouns like dog door, bark recognizer, remote, even bark.
Right. So by looking at the nouns, you're starting to identify the building blocks of the software system.
You got it. And those nouns often become the names of the classes in your design.
Okay.
This is where we start to transition from words on a page to a more visual representation of the software.
Right.
Something called a UML class diagram.
I've heard of UML diagrams,
Yeah.
but I'm not sure I fully understand them.
Well, UML class diagram is basically like a blueprint for your software.
Yeah.
It's a visual way to represent the classes in your system, their properties, and how they relate to each other.
Okay, that makes sense. So how do we go from identifying the nouns to creating this visual diagram?
The book walks you through it step by step. So for the dog door, you would add classes like dog door, bark recognizer, remote, even bark.
Okay.
And each class has these things called attributes, which are like its characteristics or properties,
Okay.
and operations, which are like what the class can do.
So for dog door, an attribute might be whether it's open or closed,
Right.
and then an operation might be like open or closed.
You got it. And the diagram also shows the relationships between classes. Like, for instance, the bark recognizer is associated with the dog door.
Yeah.
Because it needs to be able to tell the door to open when Fido barks.
It's not just about the individual pieces, it's about how they fit and work together as a system.
Exactly. And that's what makes object-oriented design so powerful.
Yeah.
You can create these complex systems by combining these individual objects and defining how they interact with each other.
This is making a lot of sense.
Good.
It's cool to see how you go from like a simple description of a problem
Yeah.
to a visual representation of the software solution. Before we move on, is there anything else about this transition from the text to the class diagrams that we should highlight?
Well, one important aspect is this concept called multiplicity,
Okay.
which describes how many instances of one class can be associated with another.
I'm not sure I follow. Can you give me an example?
Sure. So in the dog door example, one bark recognizer can recognize multiple barks from Fido right.
Yeah, that makes sense.
So in the UML diagram, you'd show this relationship with like a multiplicity notation.
Okay.
And it helps clarify how many objects can interact with each other, which is essential for understanding the structure of your software system.
Right, so it's like saying one remote control can operate one or more dog doors.
Exactly. It's all about clarity in that blueprint.
That's a great point. It's like these small details that can make a big difference in the long run.
Right.
I'm definitely seeing the value of these class diagrams now.
Good.
There's another important concept that plays a key role here in making your software adaptable to change,
Uh-huh.
and that is delegation.
Delegation.
I remember you talking about that earlier. Remind me how it works and why it's so important.
Sure. So let's go back to that bark recognizer.
Okay.
Imagine you want to improve it so it can handle different dog barks
Yeah.
or even other sounds.
Okay.
With delegation, you can change how bark recognizer works without affecting the other classes in your system.
So instead of every class needing to know exactly how bark recognizer works, they can just rely on it to do its job.
Exactly. It's like giving bark recognizer the responsibility to handle all things bark related.
Okay.
Other objects don't need to know the specifics, they just ask it to do its job.
So it's about like defining clear responsibilities
Right.
and then letting each object handle its own tasks internally.
Hmm.
This makes the system more modular and easier to adapt to changes.
Exactly. Think of it like a well-organized team. Each member has a specific role, and they can focus on their tasks without worrying about what everyone else is doing.
This is fascinating. It's amazing to see how these concepts can be applied not only to software design, but also to how we think about teamwork and problem solving in general.
Absolutely, and that's one of the things that makes object-oriented design so powerful.
Yeah.
It's not just a set of technical rules. It's a way of thinking about the world and breaking down complex problems into manageable pieces.
This has been a great start to our deep dive.
Yeah, it has.
We've covered a lot of ground from encapsulation and use cases to class diagrams and delegation.
For sure.
What are some of the key takeaways you would want our listener to remember from this first part of our discussion?
Or I think the biggest takeaway is that object-oriented design is all about creating software that is flexible, maintainable, and reusable.
Yeah.
By using techniques like encapsulation delegation and by, carefully considering the needs of the user, you can create software that's not only functional but also elegant and adaptable to change.
Right.
And remember, these principles can be applied way beyond software development. They can help you approach problems in a more structured and systematic way no matter what field you're in.
That's great. Yeah, that's a great point to end on.
It is.
I'm excited to keep learning more in the next part of this deep dive.
Me too.
All right, thanks.
You're welcome.
It's amazing how these concepts, while rooted in software design, have such huge applications in other areas of life.
Yeah.
It's like a new way of thinking about organization and problem solving.
It is. And what's fascinating is that we've covered so much ground already.
Yeah.
But it really boils down to just a few core principles of this object-oriented design.
Right.
So we've seen how encapsulation helps manage complexity
Yeah.
by hiding information within objects and then exposing like a really clear interface.
Right. It's about keeping things tidy.
Exactly.
And then we talked about those use cases,
Yes.
which help us understand what the customer actually needs,
Right.
and then how we can actually analyze those use cases to find potential problems and then design really robust solutions. And then, of course, there's delegation,
Yes.
where we're basically assigning responsibilities to specific objects, making the system more modular and adaptable to change.
Right. It's almost like building with Lego bricks.
Oh, yeah.
Each object is self-contained, and you can combine it with others to create more complex structures.
Yeah, and just like Legos, you can swap out or modify individual pieces without affecting the whole structure.
Exactly. And that's really a game changer when it comes to maintaining and updating software over time.
That's a huge plus.
Yeah.
Speaking of details, there's another interesting point that the book raises about Rick's guitar shop.
Yeah.
It encourages using these custom-tailored objects
Uh-huh.
to represent specific concepts in the application.
Right.
Can you elaborate on that a little bit?
Sure. So instead of using like generic data structures,
Okay.
like strings to represent guitar properties,
Okay.
the book suggests using what are called enumerated types,
Okay.
or even custom classes to encapsulate those concepts.
So instead of using like a string that says Fender to represent the guitar builder,
Right.
you'd create an enumerated type called builder
Yes,
with specific values like Fender, Gibson, Martin, and so on.
exactly. It might seem like a small detail, but it actually has a big impact on code clarity and correctness.
So it's not just about what the code does, but how readable and understandable it is for other programmers.
You got it with strings.
Yeah.
It's so easy to introduce typos.
Oh, yeah, I can see that.
Like imagine accidentally typing Fender with a lowercase f instead of Fender with a capital F.
Yeah.
Suddenly your search is broken.
Yeah.
But with these enumerated types, the compiler can ensure that you're using valid values.
Oh, so it's like having a built-in safeguard to prevent those errors.
Exactly.
And keep the code consistent.
And it makes the code more expressive.
Okay.
When you see builder.fender, you instantly know what it represents.
Yeah.
Whereas a string like Fender could mean anything.
Right. You don't know what that refers to.
Exactly.
So how can our listener apply these principles to their own projects?
That's a great question.
What are some steps they can take to create more flexible and maintainable software?
Well, first I would say embrace encapsulation.
Okay.
Look for opportunities to group related data and behavior into these nice cohesive objects.
So start by asking, what are the core concepts in my application?
Right.
And then what data and actions belong together?
Exactly. And then think about how to design those objects to hide that complexity
Yeah.
and present like a clean and simple interface.
Right. So you're putting on a friendly face for the other objects in the system.
Exactly.
You don't want to overwhelm them with like all the internal workings.
No, you just give them simple ways to interact.
Yeah. It's about making each object responsible for its own little world
Right.
and then interacting with other objects in this really clear and predictable way.
Precisely. And once you've got that encapsulation down,
Yeah.
you can start thinking about delegation.
Okay.
So ask yourself, which objects could handle specific tasks?
Yeah.
And how can I design my system so that changes in one part don't cause problems elsewhere?
Yeah, because that can be a nightmare.
Yeah, it can be a huge headache.
So it's like you're assembling a team of experts, each specializing in a particular area, and then you're letting them do their thing without micromanaging them.
That is a great analogy.
And don't forget the importance of understanding your customers' needs.
Oh, it's crucial.
Before writing any code, gather those requirements and create those use cases that
Yes.
capture how the system should behave.
Right. And those use cases are going to guide you through that whole design process
Yeah.
and make sure you're building what the customer actually wants.
Because it's easy to get lost in the technical details and lose sight of the bigger picture.
For sure.
Like, software should be solving problems for people.
Absolutely.
And the better we understand those problems, the better our solutions will be.
It's so true.
And good software design is iterative, right?
Yeah. Gotcha.
You're rarely going to get everything perfect on the first try.
Oh, definitely not.
As you build and test, you're going to discover new requirements.
Yeah.
You're going to uncover hidden problems.
Right.
And you're going to refine your understanding.
It's a process.
So it's a process of continuous learning and improvement,
Uh-huh.
embracing experimentation, and being open to refining your approach along the way.
Like sculpting a masterpiece.
Oh, I like that.
You start with a rough block of marble and gradually chip away at it, refining the form and revealing the beauty within.
That's a beautiful way to put it.
Thank you.
It's not just about writing code, it's about crafting something meaningful and elegant.
Exactly.
And imagine that satisfaction, of taking this complex problem, breaking it down, and creating a solution that not only works, but is also adaptable and a joy to work with.
Yeah, that's the power of object-oriented design.
It's not just writing code, it's crafting a masterpiece.
I like that.
It's funny, we're talking about software design,
Yeah.
but these principles feel so applicable to life in general.
I agree.
Breaking down complex problems, thinking about responsibilities, adapting to change.
Uh-huh.
It's almost like a philosophy for problem solving.
It is, and it's fascinating how closely those object-oriented principles mirror how we think about the world.
Right, we naturally categorize things. We assign roles. We delegate tasks.
Sure.
It's like we're wired for object-oriented thinking.
It makes you wonder if that's why it's so effective,
Yeah.
because it aligns with our natural way of understanding the world.
That's a really thought-provoking idea.
It is.
And it speaks to the wider relevance of these concepts. Like, even if you're not a software developer, understanding object-oriented principles can help you approach problems in a more structured and systematic way.
Absolutely.
So as we wrap up this part of our deep dive into head-first object-oriented analysis and design, let's leave our listener with one final provocative thought.
Okay.
What do you got?
Okay, so thinking about your own projects,
Yeah.
where could you apply these principles
Yeah.
to create more flexible and robust solutions?
Yeah, where are you facing complexity, rigidity, or like a fear of change?
Yeah, could encapsulation delegation or a deeper understanding of customer needs help you create something truly remarkable?
That's a great question to ponder.
I hope so.
And remember, the journey of learning and applying these principles is just as rewarding as that end result.
Oh, definitely.
So embrace the challenge, have fun, and keep on crafting those masterpieces.
I love it.
It really is interesting to think about how these software design principles apply to so many other parts of life.
It is, yeah.
It's like it unlocks this whole new level of problem solving.
Yeah, and it highlights the universality of good design principles, whether you're building software at a team or even just organizing your thoughts. The principles of clarity, modularity, and adaptability are always going to be relevant.
That's so true. It's about creating systems that are not only functional, but also like elegant and resilient and easy to understand.
Exactly. And head-first object-oriented analysis and design really does a fantastic job of illustrating these principles.
It's just
Through engaging examples and that visual approach it uses makes it so much easier to grasp even some of the more complex concepts.
for sure. It's definitely a book that can change the way you think about software development.
It can, yeah.
So as we wrap up this deep dive, what are some key insights you'd like our listener to take away from our discussion today?
Well, I think the biggest one is to remember that object-oriented design is way more than just a set of technical rules. It's a way of thinking, a problem-solving framework that can really be applied in a lot of areas of life.
It's about breaking down complexity, creating modular and adaptable systems, and focusing on those needs of the user.
Precisely. And the beauty of it is that it's not an all-or-nothing approach.
Yeah.
You can start by incorporating small elements of object-oriented thinking into your work and kind of build from there.
So even if you're not building these large-scale software applications,
Right.
these principles can still be super valuable in your everyday work and life.
They can absolutely, and don't forget that the book is just the starting point.
Yeah.
The real learning comes from applying these principles to your own projects, experimenting, making mistakes, and refining your understanding as you go.
Yeah, it's a journey of continuous learning and discovery.
Uh-huh.
And that's what makes it so exciting.
It does.
So to our listener, we encourage you to pick up a copy of Head First Object-Oriented Analysis and Design and embark on your own deep dive into this world of object-oriented design.
It's a good one.
You might be surprised at how it changes not only the way you write code, but also the way you think about the world around you.
I think you will.
That's it for this deep dive. Thanks for listening.
Thanks for having me.